Authentication is the cornerstone of secure web applications. It is the process that determines whether a user is who they claim to be. In the digital world, where sensitive data and personal information are frequently exchanged, robust authentication mechanisms are essential to safeguard user accounts and prevent unauthorized access. Traditionally, web applications have relied on session-based authentication. When a user logs in, the server creates a session for that user and issues a cookie containing a session ID, which the browser stores. With each subsequent request, the browser sends the cookie back to the server, which validates the session ID and grants access if the session is valid. Session-based authentication has its strengths, such as being well understood and straightforward to implement using existing web frameworks. However, it also has limitations, particularly concerning scalability. Storing session can be resource intensive, especially for applications with many users, and it can complicate the architecture of distributed systems where the user might hit different servers for different requests. Token-based authentication emerged as an alternative, addressing some of the scalability issues. With this approach, the server generates a token upon successful login and sends it back to the client. The client then includes this token in the authorization header of their HTTP requests. This method doesn't require the server to keep a record of each user's session, making it more scalable and better suited for modern applications, including mobile apps and single-page applications. JSON Web Token (JWT) is a form of token-based authentication that has gained popularity due to its simplicity and versatility. JWT is a compact URL-safe token format used to encode claims between two parties, typically a client and a server. A JWT consists of three parts, each separated by a dot. Header. The header typically consists of two parts: the type of token, which is JWT, and the signing algorithm being used, such as HMAC, SHA-256, or RSA. This is encoded as a JSON object, and then base64 URL encoded to form the first part of JWT, payload. The payload contains the claims, which are statements about an entity, usually the user, and additional data. Claims can be registered, that is, predefined, public, which means custom defined, or private, agreed upon by the parties involved. Like the headers, the payload is also base64 URL encoded to form the second part of JWT, signature. The signature is created by taking the encoded header, the encoded payload, a secret, and the algorithm specified in the header. The signature is used to verify the token's integrity and ensure it hasn't been tampered with. The resulting JWT looks like this, where first part is the header, the second part is the payload, and the third part is the signature. When the JWT is sent back to the server with a client request, the server decodes the JWT, verifies the signature, and if valid, processes the request based on the claims in the payload. The simplicity of JWT, where the token itself contains all the relevant information, makes it stateless and suitable for both authentication and information exchange in a variety of applications. The use of JWT typically follows a straightforward process. A user provides the credentials such as username and password to the server. Upon successful authentication, the server creates a JWT. The server encodes the user's information and other claims into the payload, selects an appropriate algorithm for the header, and then generates a signature using a secret key. The server responds to the client's authentication request by sending back the JWT, usually in the body of the response or as a cookie. The client stores the JWT, often in local storage or session storage, and includes it in the authorization header of subsequent HTTP requests. When the server receives a request with a JWT, it first validates the token. The server checks the signature to ensure the token is authentic and has not been tampered with, and then it verifies that the token is not expired. If the JWT is valid, the server grants access to the requested resources or services. Since the claims in the token includes the user's identity and potentially their roles or permissions, the server can make authorization decision based on this information. JWT streamlines client-server interaction by reducing the need of continuous authentication requests. After initial authentication, each client request carries the JWT, allowing the server to verify that user's identity quickly and securely without needing to query a database or maintain a session state. Now, let's open the code editor and understand how JWT is implemented in the backend. Here, I am using an Express application. The registration endpoint /register allows new user to sign up by providing a username and a password. We use bcrypt to hash the user's password before storing it. This is a security best practice as it protects the user's password even if the data store is compromised. Upon login in at /login endpoint, the server verifies the user's credentials. If the credentials are correct, the server generates a JWT using the JSON Web Token library. The JWT includes a payload which is then signed with a secret key. The token is sent back to the client, which will use it for subsequent authenticated requests. Once the client receives the JWT after a successful login, it stores the token typically in local storage. The storage mechanism allows the token to persist across session, making it a better user experience. However, developers must take precautions to protect against potential cross-site scripting attacks when using local storage. The Express app includes a middleware function, Authenticate JWT, which is responsible for validating the JWT on protected routes. The middleware checks for presence of the token in the authorization header, verifies the token using the same secret used to sign it, and either allows the request to proceed or returns an error if the token is invalid. When the JWT is invalid or not present, the server responds with a 401 unauthorized or 403 forbidden status code. This let the client know that the request cannot proceed without proper authentication. On the front-end side, we have a React application setup that interfaces with our backend. Here's how the front-end component manages the authentication flow. User registration component register.js presents a form to the user, allowing them to enter a username and password to register. Upon form submission, it sends a post request to the backend's /register endpoint. The backend responds with a success message, which the frontend displays to the user. User login component login.js. Similar to registration, login component also collects users' credentials and send them to /login endpoint. If the authentication is successful, the backend returns a JWT, which the frontend stores in local storage. This token is then used for authenticated requests to the backend. Protected route component protected.js. This component attempts to access a protected resource by sending a GET request to the /protected endpoint. It includes the JWT in the request header to authenticate. If the server validates the token successfully, it responds with the protected content. If not, the server sends an error message which the frontend displays to the user. React Router and navigation. We are using React Router DOM for setting up client-side routing that allows users to navigate between the registration, login, and protected page components. This implementation represents a straightforward example of JWT authentication in a full-stack JavaScript application. It illustrates an end-to-end process from user registration to secured access to resources. Remember that in a real-world scenario, you would need to implement additional layers of security, manage tokens more securely, potentially with refresh tokens, and handle user data with a proper database system. JWT authentication has found its place in modern web development as a flexible and scalable method for managing user sessions and securing communications between clients and server. Its stateless nature and ease of use across services make it particularly suitable for today's distributed systems and microservices architecture. Despite its many advantages, it is crucial to be aware of security implications of using JWTs and to implement appropriate measures to mitigate potential risks. By following best practices, developers can leverage the benefits of JWT authentication while minimizing vulnerabilities. If you found this video helpful and would like to see more content like this, please don't forget to like, share, and subscribe to support the channel. Your engagement helps us to create more valuable discussions and guides. As always, happy coding.